So in the last class, we discussed about the concepts related to limits. Now I'll be showing you some of the problems which students have sent me and try to solve them. So we know limits aren't concerned with what is happening at x is equal to a. Suppose this is a function fx and we have to find the limit at a. So limit is not concerned with what is happening at x is equal to a, but it is what is happening around x is equal to a. So in at some occasions, limit at a point and the function value at a point are different. So let's see one problem. Limit x tends to 0, 1 minus cos x, and so first we try to substitute 0. In that case, we know cos 0 is 0. Cos 0 is 1 and x is 0. So this will give us 0 by 0, undefined. So function will not exist at uh, x is equal to 0. Now let's find out the value of function near for the values of x near 0. So if we put 0.1, 0.01 and 0.001, and this is negative 0.1. So if I put 0.1, I would get 0.499, and here I would get 0.0049, and here I would get 0.0049. And if it is negative 0.01, it would be negative 0.0049, and this would be negative 0.00049. Okay, so we see that as the function is moving towards value of 0, as x moves in towards 0 from both the sides. Okay, so we see that function is moving towards value of 0 as x is moving towards 0 from both the sides. So we can say that both the function value doesn't exist at x is equal to 0, but when x tends to 0, the limit of this function is 0. So we can say that limit had a function even though limit of a function had a value even though function did not exist. Now we'll do another problem. Okay. So find limit x tends to 2, and we can write like this. This is the greatest integer function. It is some denote like this in some books, or it is like this. This is a greatest integer function. So it is denoted by these symbols for any real function, and it rounds off the real number down to the integer less than the number. Okay, so it rounds off the real number down to the integer less than the number. For example, if it is like 1.15, then it rounds off to 1. Then it is 4. So -4. Okay. So let's find left hand limit and right hand limit. So when it is left hand limit, x tends to 2 minus means the left hand side of 2, and that is of x. So here we put x as 2 minus h because it is slightly less than 2. H may be a very small value like 0.00001, but this will be still be a small value less than 2. So since and h is positive and very small value, so 2 minus h will be a value very close to 2, but it will be still smaller than 0. So this limit x tends to 2 minus is equal to limit h tends to 0, and this is 2 minus h. And this is equal to 1. When h approaches 0, this will be equal to 1. Okay. Now let's take right hand limit. So in right hand limit, limit x tends to 2 plus, and okay. So here x is 2 plus h. Okay. So we can say that limit h tends to 0, so this will be equal to 2.00001, which will be equal to 2. So we can see that left hand limit is not equal to right hand limit. So limit x tends to 2, x, it does not exist. Okay. So we did put here x is equal to 2 minus h for left hand limit because it is h, which is a very small value like 0.001. We subtracted from it and we saw the left hand side of 2, and the greatest integer function, it rounds off to the real number less than the number, down rounds off to down to the integer less than the number. So this came out to be 1. For right hand limit, it was 2 plus h, though it was very slightly greater than 2, it rounds off to 2. And we saw that left hand limit is not equal to right hand limit in this case. And so the limit does not exist. Now we have to find estimate following limit. Limit x tends to 2 cos pi by t. So if I change this and we can make it tends to 0. Okay. So let's do this using table of values. Okay. So this is FD cos pi by t. So we get 1. So when we substitute the values from both sides of 0, we get 1, 1, 1. But we can estimate limit to be 1 in this case. But if we check with other values, like if we put f1, yes, so this gives cos of 2000 pi, which gives 1. Then we can check with this 2001 and we'll get cos of 2001 pi. We get -1. Now we'll check to 1 or 2 more values. Like we can check with f of 2 over 2001. So this would give us cos of pi by 2, 2001, which would give 0. And that would give so if we check like this, this would be cos pi 4 4001, which would give under root 2 over 2. And these all values of t here are less than 0.001. So by definition of the limit, all the function uh, values should be approaching the same value as t gets closer and closer to point A. So here if we draw the graph, it would be something like this. So as function value moves towards t is equal to 0, the function starts oscillating and is more frequent as we move closer and closer to t is equal to 0. In order for a limit to exist, the function be must settle down to a single value. And as it doesn't settle down to a single value, limit doesn't exist. So in limits, we are not concerned what the function is actually doing at the point. In equation, we are only concerned what is happening around the point. So we can see that using table of values does not always give us a correct limit. So limit x tends to 0 sine x minus 2 cos x minus 1. So to find this limit, we see that when x tends to 0, either x tends to 0 plus or 0 minus, we see that cos x will tend to 1, but it will be less than 1. Okay, because x is tending towards 0, but it is not 0. So this will be cos x will be less than 1. Okay, so cos x minus 1 tend to 0 minus when x tends to 0, sin x tends to 0. Okay, so sin x minus 2 will tend to negative 2. Okay, so the numerator is tending towards minus 2 and denominator is tending towards 0 minus. So it will be a sort of, so the limit L will tend to infinity, positive infinity. We can also solve this more algebraically, like sine limit x tends to 0. So this is sine x minus 2 can find the limits. That's okay. So this will be negative 2 and this will be negative infinity. Okay, so same way we'll do for this limit x tends to 0 plus sin x minus 2 and limit x tends to 0 plus 1 over cos x minus 1. So this would give infinity. So limit of this function tends to infinity. If we see the graph of this, it would be something like that. This, which will also show that as the graph approaches 0, the value of the function is going towards infinity. Okay. Now we'll try one more problem. X tends to 0, 5x cubed plus 8x squared. If we put x is equal to 0, it becomes undefined, 0 by 0. So we need to simplify. So what we can do is we can take the x square common. So this gives 5x plus 8. And 3x square minus 16. So now as we put x is equal to 0, it becomes 8 over negative 16 and we get the value. Now the next problem is limit x tends to 3, x plus 6 minus 3 and x minus. So if you put x is equal to 3, it becomes undefined and it is 0 by 0. So we can do rationalization here. And what we can do is we can multiply this limit x tends to 3, x plus 3, x plus 6 minus 3. And we can multiply denominator and numerator. This. Now we can know that a minus b, a plus b is equal to a square. We can use this formula having this as a and this 3 as b. So now if we solve it, this will be x minus 3 and under root x plus. So this gives us limit x tends to 3, x minus 3. If we put 3 here, we will get under root 9 plus 3, which would be 1 by 6. So in this case, we multiply by with its conjugate, numerator and denominator, and then we simplify and we could get it. So this is one way of doing and getting limits. Now, if the question is like this, limit x tends to 1 and 2x minus 3 under root x minus 1 and 2x square plus x minus 3. If it is simplified and this is 2x plus 3 and x minus 1. This will give limit x tends to 1 we know in the denominator we can again put x minus 1 to use here a minus b and a plus b. That would give under root x minus 1 and under root x plus 1. Now as we put x is equal to 1, this will give us 2 into 1 minus 3 and this is 5. So this will give minus 1 over 10. So the limit of this function comes out to be 1 or negative 1 over 10. Now the next problem which we can do, limit 1 plus and this gives 2 minus x. So when we are solving this question, we can put x is equal to 1 plus h, which is a very, h is a very small value. And then if we put this, it will be limit x tends to 1 plus and 1 minus h. So this would give us 1 minus x would give negative 2 is negative 1 over h. So we see here that as h tends to 0, negative 1 over h tends to negative infinity. Because as h tends to 0, 1 over h would tend to infinity and negative 1 over h will tend to negative infinity. So two 2 raised to power minus 1 over h would tend to 0 plus. We know how the graph of 2x is 2 raised to power x is and 2 raised to power minus x is. So graph of 2 raised to power x is like this. So as x tends to negative infinity, the graph 2 raised to power x tends to 0. So when negative 1 over h tends to negative infinity, the value of function tends to 0, but it is positive. And same way, if the graph and negative, so this would be, so this would go to 0 plus and 2 raised to power, it will be around 0 is 1. Okay. So this whole value here is around 1, uh, tends to 0 and 2 raised to power 0 is 1. So the limit here would be equal to 1. So we can say now we'll meet in the next class with the next set of problems. Thank you.